Hey everyone, in this video I want to talk about the Microsoft Entra Private Access capability. Now we're used to the idea of thinking of identity as the perimeter to control access to our applications. I've done a lot of videos in the past about controlling everything with Entra. And so I can think I'm going to put here at the center, I have my Entra tenant. And the key point here is that there's all these different applications that I can federate, i.e. trust Entra for the authentication. So sure, there's things like Microsoft 365, there's Azure, there's Dynamics, there's third-party SaaS applications. There's a huge gallery of applications available in Entra that I can go and add. But if it speaks cloud, if it speaks OAuth or OpenID Connect or SAML, chances are I can go and add it and leverage Entra as that authentication, that authorization to control all of that access. Now, if I have applications that maybe don't speak cloud, they're not available on the internet, well, then we have the option that I can do it on premises. I can think, for example, my on-premises network. Well, in my on-premises network, I'll draw this really big. So I've got some web application. And what we would do is we could use Entra App Proxy. So App Proxy has an agent or a set of agents. This establishes a connection this way. And so this is Entra App Proxy. And then once again, I can make that available via Entra. I can do things like pre-authentication. I can apply conditional access, and we'll get back to that. But I can get that seamless access and authentication now for those web. And that's the key point, web-based applications. I can also do things around the internet. So then we have these other sites that maybe they don't integrate with Entra for the authentication. So I just have other internet things. And I did a video a couple of weeks ago about the idea that, well, there's also Entra Internet Access. And this enables me to create basically security profiles that say, hey, yes, I can access these sites. I have to apply conditional access before I can get to them. But I can control all of those different types of access. And the key point for all of these things, and it's really, I think of it as the superpower when I always think of Entra, is conditional access. So around anything I'm doing, conditional access is that shield. It's that nice protective barrier that if I want to get a token to be able to talk to anything, I have to pass the policies that I've applied to those very specific sets of conditions, particular apps, particular health, particular risk, particular custom attributes. All of those things I can look at and make requirements for different policies and then apply controls like strong authentication, be hybrid joined. The device needs to be healthy per Intune or Defender. So all of these different things are going via conditional access. And I really do think of that as just a key point to everything we want to do. But realize, and there are other things. So if we talk about this idea of, okay, my on-premises, well, there are other types of applications I have in here. There are applications that are non-web. So I have non-web applications. And I'm now thinking of anything that is TCP or UDP based. Now, traditionally, the way we would solve this is the organization would have a DMZ. So it's demilitarized zone network. And in there, I'd put different services. I would put in services like VPN. So I get these virtual private network, these tunnels. And what the VPN does, remember, let's give ourselves a bit of space. If I think of Well, I've got my machine. So my machine is over here. And with a VPN, what's happening is it establishes a tunnel. So I get this tunnel established to the VPN service, which then obviously gives me a connection into that network. So I have this tunnel. And the challenge with this approach is that once I've done whatever check it had, hey, log in, authenticate, I've now just really got just free range access to everything in that network. It's a network level access solution. There's also things like I might have internet proxies. So, hey, things wanting to talk to the network, maybe making some things available to the internet. I have firewalls, but I have a bunch of services that I'll put and have to manage in this network. So all of this is infrastructure. And if I think of this cloud first way, I think of things like zero trust. I don't like this. There's a number of tenets to zero trust, which I'll talk more about, but you always kind of want to assume breach. You want to verify explicitly. I want least possible access to things, which is not a tunnel directly into the network. If one thing was compromised, I now have free reign. We've seen some of these major security attacks actually go through some compromised device and then it's got free range. So I don't want to do this. I don't like just this open tunnel. I really want to try and move away from that. And so great. These things we don't want. We want to move all of these services. We want to move it outside to follow zero trust principles, because I do want to verify explicitly every access to some specific thing I want to validate. I maybe have different requirements to be able to access that. I want to have the least possible access that's just enough to do what I need to do within that particular context of my security. And again, I want to assume breach. I want to have very detailed telemetry to see everything that's happening and look at things like risk before I grant any kind of access. And so this is where, as you would expect, we start getting into this idea of this new set of services. So what we're looking at is this secure access service edge. So I'm just going to write, I keep doing my pen wrong today, my secure service edge. And I'm going to just draw this as a big bucket going around here. So it's this edge set of services. And the whole point of what this is going to do is it provides a number of different things. Now, again, I said I did a video a few weeks ago where I talked about the internet access side of that. That's a secure web gateway, an internet proxy that's making sure I'm only visiting the sites that, hey, are safe, so I'm protecting the users from themselves. I don't accidentally click some bad link. I can put controls, anti-malware, intrusion detection, intelligence all around there. There's cloud access security brokers to enforce policies. Longer term, there's things like branch connectivity. But I want to focus on the idea of zero trust network access. So that idea of that private access for these non-web applications, but hey, I'm not just having this very broad tunnel of VPN. I want to focus on validating the access every time, anytime I'm trying to access something. I want to understand the posture from a security perspective of the user and their device. And it should work no matter where they are. And then that's beneficial, hey, the internet, those protections, no matter where they are, but also no matter where they are, they should be able to access these services. And I want it done in such a way that I'm not just part of my internal network. I want to apply those zero trust principles. And so that's exactly what this solution is doing, this secure services edge. Now, remember, I still want it to be highly performant. And if I think from a Microsoft perspective, I think they have something like over 170 edge sites. So potential points where I as a client can connect to, and there's like 70 Azure regions, over 2 petabytes per second of capacity. So I'm going to be able to connect to something close to me, and there's massive amounts of network bandwidth to support what I'm trying to do. And again, the key point here is every single thing I'm doing, I'm still going to apply this conditional access. Again, that's the superpower when I think of Entra. So how do we get going with this? So the first point is obviously, well, this client can be anywhere. I have to get something on the client to know that it needs to start integrating with these services, what it needs to send to this edge service. So what we have is we install this global secure access client. Now what this does is it connects to the endpoint on this edge. So I can think about, hey, it's making this connection to the edge. And then as we'll see, everything it actually wants to go and talk to, it still has to go and flow through Entra for that authentication, which means to go and get the authentication, it then has to flow through the conditional access to go and get whatever tokens it needs so it can go and carry on around its way. So I'm still applying conditional access for every single thing I'm doing. And as I mentioned in the internet access video, it's not like it's a different client. This one global secure access client is used for both the Entra Internet Access and it's going to be used for this Entra Private Access. I'm using the same Entra portal to manage it. It's the same conditional access that I'm used to doing. There's not a whole set of new learning to do. It's just from the client's perspective, it does establish different connections. I could think of it as these gRPC HTTP2 tunnels to the Entra edge. One for the internet access workloads, one for the private access, one for the Microsoft 365. And the key point here is it is establishing this to the Entra edge. It is not establishing it over here to this. In fact, I'm going to give myself a bit more space and we're just going to get rid of this now. So we don't want to do this. We don't want this nasty tunnel idea. We want to get rid of that and never want just this open connection to those networks. So we're going to get rid of those things. So it is only ever talking to this edge and it has to go through all of the checks to make sure, well, should I be trying to get to this service over here? Am I passing the conditional access policies? Now this installs a network filter driver in the operating system. So all packets go through that stack. And then if it matches the pattern of what the global secure access client cares about, then it gets sent here so we can go and get processed by the edge. Now it is a new client. I could deploy it using any standard enterprise mobile device management solution or group policy. It doesn't matter. It's just a package I'm installing. It is today a standalone installation. I think as this GAs and then goes further, I think the way it updates and deploys will likely change it, become more integrated. There are other operating systems and platforms like iOS and Android and Mac that are all being worked on to be able to leverage this. So broad platforms, and again, it doesn't matter if this is at home, in an office, in a Starbucks, it's just going to work. So let's have a quick look at this client. So if we jump over to my machine, here we go. So I've installed the client already. And what I'm going to quickly do is just remove my little logo. If I look in the corner, you can see I've got this little icon. This is the Global Secure Access icon that shows me its status. Now, if I right click on it, you'll notice I do get some options. I could change who it is logged in as because obviously I'm authenticating the client because then that's the user it is running as. So that's where, hey, if I have conditional access policies targeting particular users or groups users are in, I can change that. I can do things like pause, resume, restart, collect logs. Now, just to note, this is in preview at time of recording. Once again, when it GAs, there will be abilities to control which of these are exposed to end users. For example, if I'm thinking of internet protection, maybe I don't want them to be able to pause it. And so there will be restrictions on these. But also I have this advanced diagnostics option. So if I fire up the advanced diagnostics, this is a really nice, I'm going to leave this up and running, so we're going to use this. I'm going to make it a bit wider. But it gives us basic information. I can see my client version down here, which may be useful if I'm checking. It has a health check. So this is really nice. So I can go through and see all the different things that it's leveraging, if there's any problems. So I would go and check this if I'm seeing something strange going on. But I can see things like, hey, yeah, look, the tunneling has succeeded. Do I have my token? Magic IP. These are the Entra Edge. But I can go and see all the different things it's doing. I can see my forwarding profiles. I can see when it was updated. So this is what it goes and fetches from that Entra Edge. And then I can see the different rules. So I can see there's Microsoft 365 rules, there's internet access rules, and there's private access rules, which again, we're going to come back to. And there's hostname acquisition to look at things around, hey, the name resolutions it's trying to do for different possible targets. And I would have to start collecting if I want to view that data. So this is all about the DNS. But then I can actually view the traffic. And this is what we're going to actually look at later on, because this will help us show some of the fantastic things it's doing. So these are all the layer 4 packet flows. So the client is up and running, and we are good to go. Well, so now I need to actually start telling it which traffic and what do I want to make available. So we're going to focus on this private access. So I have things over here. I have things over here that I want to make available. Now, when I think about this, obviously it's a private network. So how does this Entra Edge go and communicate to it? Well, just like the old app proxy, which has its agent, now we have this concept of, we have these connectors for Entra. So I deploy connectors. And the reality is these connectors will actually replace the app proxy agents. So this connector supports both the Entra App Proxy web services, and it supports the non-web services. So I'm going to deploy these connectors. So I've got 2 of them deployed in my private network. And we can see these. So if we go and take a look at our environment, so I can go down to, I'm looking at the global secure access environment of the machine. And if I see, I've got connect and then connectors. And we can see I've got 2 connectors in my default group. So the whole point of this is, well, yes, I can add multiple connectors. And I would want to do that very likely when I think about, well, I want that ability to have resiliency. I want to be able to handle greater load than just one agent in a particular OS instance. And that's all this is. The agent is just saying I install into a Windows Server operating system that lives in that network. So if I think about this environment over here, these connectors have to be able to get to the target. So I'm installing multiple connectors. Now I might want to create different groups of connectors because, well, hey, there's just a default group that I'll use for regular targets. But maybe I've got some really high priority targets that I want to prioritize. I want to make sure they don't conflict with other traffic going to other services. I want to make sure they have some dedicated connectors to process their traffic. So I might create a high priority group with their own sets of connectors just for these particular applications. So I can create these different groups. I create the connectors, but then as you would expect, these connectors are then establishing that connection. So it's always out this way to the Entra Edge. So these are this Entra Private Access. So these connectors have the network path to be able to talk to the services I want to be able to make available. So I need to make sure if there were restrictions within the network, this does have the ability to go and talk to those targets. Otherwise, obviously, it's not going to work. Now for web apps today, I would still carry on using App Proxy. Again, this connector supports both App Proxy and the Entra Private Access. Again, I think over time that will probably converge. But the key point here now is that the Entra Private Access works with anything that is TCP or UDP. So RDP, SSH, SMB, FTP, printers, your specialized UDP streaming-based services. It doesn't care. It's just going to work. And then to use it, remember that Global Secure Access Client supports different things. And so if it supports different things, I need to say, well, which ones I want to enable. So if I jump back over to here, I look at my traffic forwarding, and I just make sure I have checked the box for private access. So I do have that enabled. It even gives you a summary of what you have published and any applicable conditional access policies. So I have got that turned on. Fantastic. So once we've done that, remember the key point here is that I want that granularity. This is not just a broad, okay, yes, just connect to everything the connector can see. I'm going to have different levels of sensitivity in my applications. I want to only allow particular ports to particular applications. I might have different data classifications that require different controls. So I want to go and add explicitly specific apps I want to make available that I could then, remember, have specific conditional access policies for. Or maybe I've got different categories of apps that need a common set of conditional access. So I'm going to define these segments that are IP addresses, that are fully qualified domain names. Is it TCP and or UDP, the ports that I want to go and make available. And so that is our next step, to actually go and add in, go with another color. I'm going to go and add in the Entra Private Access, the application, and I'm defining what is that application in terms of, hey, those IP address ranges, those fully qualified domain names. So now if we jump back over to the portal, let's go and look at that. So I'm under Applications, and I'm going to define an enterprise application. Now I've already done one for RDP to my domain controller. Again, very specific. I'm not just saying, hey, talk to the domain controller. We can see I say specifically what I want. So I said specifically, I'm making it available via its IP address or its fully qualified domain name. Now I have enabled, notice, TCP and UDP. UDP is actually more efficient. And so RDP uses UDP as a sidecar. So it has TCP for an initial connection, but then it can do the bulk of the data transfer via UDP. So RDP is actually quite a nice demo because I can show TCP and UDP in action. But I'm very specific. And then obviously I told it, well, which users are allowed to access this. But if I was going to create a new app, I give it a name. I tell it which of the connector groups it's going to use. I want to enable access with the Global Secure Access Client. And then I add my segments. Now, once again, my segments can be an IP address, so a single IP, a fully qualified domain name, a range of IP addresses inside a format, or an IP range where I can just type in the start and end. So if I did that start to end, you can just see types it in. I have to put in the ports, and then I specify, hey, is it TCP and or UDP? So I have complete control over those. Now, a really, really important point is when I'm defining these things, what I want to ensure is I don't have overlap. So you might be used to traditional IP routing where I could have a broader route with maybe a /24, and then I could do a more specific one with a /26, and the /26 would take precedence. I do not do that here. I do not want overlap between the different enterprise apps that I'm defining. It will cause problems, so make sure they are super, super specific. So I'm never going to overlap those things. And the key point is what you saw me doing there. I'm being very, very granular. So I'm defining that particular application that I want to be able to make available. And so I would go and repeat this for many, many applications. But once I've done this, once I've defined this app, well, then it's just an enterprise application to Entra. So if I then went up and looked at my applications and my enterprise apps and I searched for that RDP, there it is. It's an enterprise application. So what that now means, if I look at conditional access, my policies, I created a conditional access policy targeting that application. So my target resource was that quick access application. And I'm going to say, look, I want it to only be a low user risk. The sign-in risk needs to be low or no risk. And I want it to do a particular strength authentication. I have my own custom authentication strength that requires the Authenticator app to be leveraged. So I've gone and applied a conditional access policy for this. So you can see I've gone through a whole set of steps now. So I defined the application, and then once I defined the application, well, now what will happen is this application is now known within here. Remember, what else did I do? I created a conditional access policy. So I added a conditional access policy. This app was added as an app in my Entra tenant. So my conditional access policy actually targets that particular application. And my GSA client has now been informed that, hey, this app is available to you, and it's these IP addresses, these fully qualified domain names, whatever those configurations were for that particular application. And I'll see that. So if I now jump back over to this, if I went and looked at that forwarding profile I talked about, and this time I'll look at my private access rules, we can see exactly this. Remember, I enabled it for TCP and UDP? Well, sure enough, there's the IP address, TCP and UDP and the port, and the fully qualified domain name, all available. So it now knows, hey, if you see this, you need to go and send this to me. So that's now just part of it. And I guess the best thing to do at this point is, can we see this in action? So what I want to start doing, let's actually start collecting. And let's open up MSTSC. So I'm using the fully qualified domain name. I could just as easily use the IP address as well. I'll hit connect. Now it's making me authenticate because my default authentication wasn't strong. So it's making me do Authenticator app. So I'm typing that in. I've passed that through. So now I've passed through the conditional access part. Now it's asking me for the actual auth to get into the RDP. So now it's going through and it's just going through that connection. So you saw, hey, I'm going to that particular machine. And now it's going and actually authenticating to that box. All of that passed through. And this is the first time I'm actually connecting to this box today. But while that's finishing off the connection, so there we go, it's popping up. Oh, I could just connect again, but you saw that. Let's do it. Now, interesting point, when I connect the second time, it's not making me do the strong authentication again. The reason for that is because my token now already has that strong authentication, so I'm good to go. So there's just, I probably should have authenticated that box already today, but there I'm connected. And if we go and look at our traffic, what we can see, let's just scroll down. So what I'm looking for is my 3389 So I can see a whole bunch of traffic related to here. And notice I can see both UDP and there's different ones for the TCP as well. So let me change order by the time, make it a bit easier for me to see. And what I'm looking for is my private access. Because I opened that website, it's hidden most of the stuff I cared about. But here we go. All right, so I'm looking here and we can see it. We can see it's at 3389 traffic. And I can see it's both UDP and TCP, and we can see it's active. It's using both of those. And if I scroll over, I can even see the amount of traffic being sent. And the key point here is most of it is the UDP. Like the bulk of the traffic, this line is actually that UDP line. So right here, it's showing me, hey, look, UDP is being leveraged for that. So I can see all of that data being performed, and hey, I can go and access that service. So that's really one of the huge points of all of this is that use of, hey, it's not just TCP, it's UDP as well. And realize in that flow, what we were seeing is this. There is no direct communication. Now, one of the things that can happen, there is a local breakout. If I was actually sitting on this network, one of the things it can do is it will still go and check the authentication, still apply conditional access, but then break out for the ongoing packets if I was sitting on this network, but it still enforces the requirements of the conditional access. But the flow is always this. I'm never bypassing this conditional access. So I had to pass those conditions, my user risk, my session risk. I had to do the strong authentication. And then once I've done that once, as we saw, the second time I connected, it didn't make me prompt and go through that again. I could also monitor in the portal. I can go and see the traffic and it would show me there as well. But I would go through and repeat this process for every single unique application, unique segment, and I would just define those through. They would all be enterprise apps. They could all have their own conditional access policies. So that's a key thing that I want to do as part of this. But I'm getting started maybe. And I had this VPN thing before, and there's a huge number of apps. And I'm like, look, sure, for the more high priority ones, I'm fine. I'll go and add all these apps. But you know what? I also just need some more generic basic access. Maybe it's to SSH or RDP or access some file shares or printers. That's just general classification stuff. And I need to kind of make that available a bit quicker. So I can also add this idea of a quick access configuration. Now I can only have one of them. So I would add multiple apps, but I can also add a quick access, which again, what are its particular segments? And once again, this quick access would be an application that will show up as an enterprise app, which means once again, I could add a conditional access policy to target quick access. And then those segments I defined would also get added and told to the GSA client. So if we go and look at my environment, I did exactly this. So here in the portal, we go back over to, and I guess while I'm here, the monitoring, we do have the traffic logs. I could look at private access, and I can look at all the different connections, the amount of traffic, the connectivity. So I have great insight into what it's doing. But back to my applications, I have this quick access option. Now you give it a name. So I called it quick access. You tell it which connector group to use. And all I've enabled in mine was TCP UDP 3389 for IP addresses 0 to 9. Now remember, my enterprise app was .10. Remember, we never overlap, which is why I stopped at 10. And then I also enabled 445 TCP, which is SMB. So I defined a quick access And once again, I could apply conditional access to it, but it just shows up as an enterprise app. If I search for quick, there's quick access. I don't have a conditional access policy applied to it, but there's absolutely nothing stopping me. I could absolutely go into this. I could create a new policy. I could target a particular app, and I could just type in quick. And sure enough, there's quick access. So I could completely define that. So the point now is I've enabled this other set of segments, in my case, IP addresses for particular sets of ports. Again, I've still not just done everything. I've still been more broad, but it's just, hey, this is maybe what I would have had available potentially in the past with some of my more basic kind of VPN scenario. And we see that in the forwarding profile. So here, my forwarding profile has those ranges, the TCP UDP for RDP, and it has my SMB. So I can see those all got sent down to my client. So it knows, hey, look, if you try and access anything in this range, do it. And so once again, let's start the collecting again. And if I was to just do 10.0. What is it? 1.5. Oh, there we go. / data. That's just an SMB share, and it opened up. So there's a file, and there's my dog. 0 sniffs. So that's just showing now how just a basic SMB working. And once again, somewhere in these logs, I would see, and it does show me the type of traffic in the file column. It shows me the private access. And there's my 445. So we can see, look, this is actually me looking at the SMB share. So I can see all of that data, but that just worked. It made it very easy to leverage, and I can see that in action. So that's that ability. Well, do you know what? I've got this more broad set of networking. I'm not quite ready to have every app up and running. Maybe over time, I'll get a bit more specific on those things. But hey, that quick access gives me the ability to make things available while I'm getting everything else figured out. Fantastic. What about, though, we saw fully qualified domain names, we saw IP addresses. Now, as a human being, I might be very used to DNS. I might be very used to just typing in single label. I just type in a bit of a name. And normally on our clients, we have this search list of DNS suffixes that it knows to add to the end to try and see if we can resolve if I just type in a single label name. Well, how do we handle that? Because people are used to DNS names. And now remember, the whole point is those fully qualified domain names that I would put here, this client does not have to be able to resolve them. Only the connector has to be able to talk to the DNS service to be able to resolve them. This just tells the client, hey, if you see this fully qualified domain name, send it this way and it will deal with it for you. You don't have to be able to resolve that fully qualified domain name. Only the connector has to be able to resolve the fully qualified domain name. But how does the user just type maybe some basic single label names, or maybe even the fully qualified name? But think of that quick access configuration. I didn't put every single fully qualified domain name. How am I handling this? So if we jump back over, what would happen? So if I go to just a PowerShell here, actually let's just, we can start collecting just for a bit of fun. Just really going to do anything. So if I try to resolve, oh, there we go, it's helping me out here. So let's just try a single label name, resolve. Now it resolved it. And it did the correct IP. That's that 10.0.1.5 that has that file share I connected to. Now the name is bizarre. It's this very, very strange name. It's added this huge GUID and then .global secure access .local. Now, that huge GUID, the 6FDD, just remember 6FDD, well, 6FDD, if we went back to the portal for a second, if we were to look at our enterprise applications, and again, we looked at quick access, 6FDD is its application ID. So it's created a DNS suffix, which is the application ID of quick access, and then it's added to that the .global secure access .local. So it's doing something weird, but it worked, right? It resolved to that IP address. So what that would mean is I could just do, I could just do the name. And it's got it down here because I've obviously tested it earlier. If I just do the name /data, it's still, now it's obviously going to go over and do that DNS lookup, but it will still give me access to that share. And there we go. So I'm accessing it. I could also resolve the DNS name, the fully qualified name. Now this time, obviously, the name is correct, and it still resolves to the same IP address. So that means as the user, I could also put in the fully qualified name. So if I did .saviltech.net, well, that opens up as well. So DNS is actually working for my client. And if I was to actually stop looking, we'll see sort of the 53s. So remember, 53 is DNS. So we can see it's actually talking to this zone, this DNS server. That's what I'm talking to do these various resolutions that I want. So there's also a DNS server, which is the app ID of my quick access. So some really interesting things are happening. Now remember, my client has zero knowledge of saviltech.net, and especially zero knowledge of that strange quick access URL that I had there. So how exactly is this working? What is being configured on the client to make those things actually happen? Now remember, when we think of DNS, on my private network, I have DNS servers. So in this network is absolutely DNS services, which my connector has been configured to use. So my connectors can talk and query those DNS servers for resolution. So when I think of that saviltech.net in my example, saviltech.net as a zone exists on those DNS servers. So that's why that is able to function. But my client has zero clue about saviltech.net. So how are all these things working? So this is part of that quick access configuration. So if we jump back over again, if I go back to my quick access, you probably noticed there's also, in addition to the app segments, there was this private DNS thing. And all I do here is, well, one, I'm telling it to enable the private DNS, and then I can add my own suffixes. I'm just entering the name. That's all I'm doing. I'm just telling it, well, saviltech.net is also a zone that's used in my private network. So I've turned on private DNS names and then told it which suffixes exist in my environment. So as part of my configuration now, what we've done is in this quick access, I've also said, hey, yes, I want private DNS. Yes, please. And then I've added my specific suffixes. Obviously, that once again gets sent up. And now it's doing a whole bunch of things on this client. Now, if I think of this client and its operating system, it has configurations. So I can think that I have my DNS service running on this machine. Now for Windows, if I want to modify the behavior of DNS, we have the concept of a name resolution policy. We have a name resolution policy table. If you've ever played with DNSSEC, you would have done configurations, say, hey, this zone needs to be encrypted, etc., etc. But what it's done now is, as part of this name resolution policy table, it's added, well, that quick access ID zone, so it's that global secure access. I know it was .local, and it's added that suffix I added to it. And what it's telling it is, with this name resolution policy configuration, these zones use a special fully qualified domain name, that ID, and these are split DNS, so these will get sent to the global secure access client. And on my DNS, there's a list of search suffixes. So it has added a default search suffix, which is that weird QAID GSA, and it's global secure access .local. Which is why when I typed in that single label name, it was single label name dot weird GUID dot global secure access dot local. So let's go and look at all of those things together. So we go back to our machine. So now I'm in here. So remember we saw weird name, the app ID of my quick access .global secure access .local. Now, if I was to open up my network properties and I look at my properties, advanced DNS, look what it did. Append these DNS suffixes, it added that quick access ID.global secure access.local. So that's why when I just typed in a single label name, what it actually searched for, it searched for single label name dot that suffix GUID.global secure access.local, which is why it then knew to go and send it to global secure access, to send it to my connector to be able to resolve the name. What it also did, if I do get, oh, there we go, DNS client policy, is it added two policies. One for that custom suffix I added saviltech.net, and one again for the giant GUID.globalsecureaccess.local. Now, it does not show me in this output the name servers, because this command only shows the name servers if it's IP addresses. And as we know, what it is configured is a fully qualified domain name for the DNS server. So that's why it's not showing there, but it has actually configured it to be, hey, for these two suffixes, those namespaces, send it to this target, which is then sending it via the GSA client. It's tunneled to the Entra edge, all the way through to go and get resolved. And now that's just working for me. And again, completely transparently from what I need to do or know, if I type in some resolver name through an application, it doesn't matter where, it's part of the OS, the core DNS configuration. If I put in a single label name, it's going to add in that weird suffix. It knows to send that to the GSA client. Or if I typed in a fully qualified domain name that was ending in the custom, I can add lots of custom suffixes, it knows to send that to the client. The GSA client sends it to the Entra edge, which then sends it to the connector. The connector then sends it to the DNS servers it uses. So those custom suffixes that I added would be ones that I use in my private network. So then these DNS servers it talks to would be able to resolve those. It sends me back the result, and it sends it back all the way here. Fantastic. But there's actually some more interesting things. It's not just transparently passing through the network. There's actually a complete DNS component that makes up part of this service. So what's actually happening here is inside this edge here is actually a DNS service. So when I'm doing that name resolution request, so hey, something's typed in here, hey, I'm trying to resolve something. Well, yes, it goes over the GSA tunnel to this special DNS service. So this DNS service actually has a cache as well. And it says, do I have what they're looking for in my cache already? Now let's say it doesn't for now. It's not in there. So it's not in there. So now it has to go over this connection, ask the connector. The connector then says, oh, I'll go and ask my DNS service. It gets the result back. So the answer sends the answer back. This gets sent the answer. And now it will add it to the cache. So the cache now has that answer added to it. Sends the answer down, and voila, I had the IP address. Fantastic. Now imagine, remember, so there's lots of points of presence edges in the makeup Entra. Well, now imagine I have a certain population of users. This is not one machine. Now imagine it's 1,000 machines. And 1,000 machines all doing the same DNS lookups. Before, what would have happened is 1,000 times it will talk to the DNS service, 1,000 times it will have to talk to the connector. It may do some caching of its own, but then, hey, it has to go and talk to the DNS server. There's a lot of load against my infrastructure. I'm using up traffic, I'm using up power of the connector, I'm using up connectivity to DNS services, and also it takes some time because it's talking to this, talking to that, responses back. The first machine does exactly that. It has to. Have to be able to go and get the record. Machines 2 through 1,000 or 10,000, whatever the number, goes here. Oh, it's in the cache. Here's the response. So only the first one has to actually go through that entire process. Every other connection for resolving that same name doesn't. It just goes and gets it from the cache. So they're going to not only save work on my connectors and my infrastructure, they're going to get a much faster response because now I'm just fetching it from the cache. And again, this is not a global cache. They would be in the same geographic location. So they're talking to the same point of presence on that Entra edge. So if I had a particular population in London, just making up locations with no reason in particular, or New York, they would be talking to different POPs who have their own caches. So the first person at each geographic location would go through the complete flow. Number 2 would just get it from the cache, 3, 4, 5, etc., etc. And so this DNS is actually fantastic. So that quick access, now I just put in the suffixes. I can still use single label names on this machine. It knows, hey, well, let's send it, try and see if we can resolve it this way. And then every other person can just go and get it from the cache based on the time to live of the record. But something may be troubling you. How did my machine resolve if it by default adds this huge GUID-based suffix? And what I said was, so this gets added to the default. So I just typed in that single label name. And then that gets sent via the DNS service, which then goes to the connector, which then queries its DNS servers to get the response. My connector and my DNS server have zero clue what long GUID.globalsecureaccess.local is. So how is that possibly working? And the way it's working is that app ID GUID.globalsecureaccess.local is known as that default special suffix that we added. So what actually happens is when that name resolution requests apo1.guid.globalsecureaccess.local is sent to this service, it strips off the GUID.globalsecureaccess.local and then just sends the single label APO1 here to the connector. And then the connector will use its default suffixes. So, hey, I typed in APO1 dot on its own, just APO1. My local DNS suffix added that GUID.globalsecureaccess.local. That got sent to here. It said, oh, it's .guid.globalsecureaccess.local. I'll strip that off and just send the single label name. So single label name gets sent over here. The connector says, oh, okay, I'll add my default suffixes, which is .saviltech.net. So now it's searching for apo1.saviltech.net. Oh yeah, I can resolve that. Here's the answer. Here's the answer. Answer is sent back. So that bothered me the first time I was looking at it, and that took me a little while to get. That's what's happening. And so the key point is it's just going to work for the users. And I have full control of, for the more sensitive apps, different classifications, I should go and add them as specific apps, because then I can add specific conditional access policies, exactly as you saw for me. I required certain risk. I required an authenticator app-based MFA. I can also have one quick access configuration, maybe from a more general sets of requirements that I've maybe not got to create dedicated apps for yet. Maybe I will over time, but I have to get that connectivity up and running. But for the end users, they're probably used to just maybe typing in a single label name. So I can turn on private DNS and have a default, which is going to be this magical GUID based, which will get stripped off when it's sent to the DNS service and then looked up against its default suffixes. And I can also add the custom suffixes. So if they do type in a full name, .saviltech.net or whatever yours are, well, remember, this client on its own wouldn't be able to resolve those names. It doesn't have a DNS resolution to what are private zones inside your company. And so the Global Secure Access client is said, hey, if you see this suffix, just split DNS, send it to me, I'll deal with it. It sends it to the DNS service, which can go and resolve those names. And it's not just blindly forwarding through. The DNS service has a cache. So only the first request actually goes through the connector, is load on the connector, is load on my DNS to get the response back. The second, third, fourth, hey, those are just going to come from the cache and save the load on my infrastructure, but also accelerate the experience of that second, third, fourth person in that particular geographical region. And again, it does that handling of the single label names for us by stripping off that global secure access zone when it sees it, to just go and use whatever those defaults are here. Now, obviously, I always talk a lot about the technology. I enjoy it a lot. But hopefully you saw the actual configuration was really, really simple. The net result of all I did really was what? I named a couple of apps. So I put in an application and I just told you what segments it was based on IP address, TCP and or UDP, the port. That's all I had to do. And then I could go and create a conditional access policy for it. And then for a larger, broader range, hey, these ports, these protocols, these ranges, yeah, I want the end user to be able to type in fully qualified domain names for my custom zone, which ordinarily it would have no way to resolve. And if they put in a single label name, hey, I want you to handle that for me as well, which we saw it does exactly. And that is it. That was my goal for this video. to just show this super powerful and for the user completely seamless technology to access, hey, my non-web TCP or UDP applications. But it's super granular. I'm only enabling just enough. I'm only accessing the particular ports and protocols I need for the job that I get to pick. It's not some broad network access. Every request, I'm applying conditional access policies based on those particular applications. And it actually would accelerate the end user experience when I'm thinking of those as resolutions. And of course, this is one part of the story. We have Microsoft Entra Internet Access. We have the regular Entra capabilities for all of our Entra integrated apps for the authorization, which applies to conditional access. And it really just gives me that full connectivity. As always, I hope this was useful. And until next video, take care.